Welcome back to Topic 8 for Algebra 1, Write, Graph, and Solve Compound Inequalities. In Part 1, we're going to focus specifically on just writing and graphing compound inequalities. Let's start off with some vocab. There are two main words that we deal with. Intersection, which is another word for and union. If we start with intersection first, or the term and, that relates to when a number is a solution to the compound inequality if the number is a solution to both inequalities. It has to satisfy both inequalities. So for example, what if we're asked to graph all real numbers that are greater than -2 and less than 3. So what I like to do is think about each part of this separately. We're asked to graph x is greater than -2 and x is less than 3. So greater than -2 and less than 3. Based on what we know in topic 7, we can graph x is greater than -2. So I'm going to mark it on my number line. Since x is greater than -2, we have an open circle, and we're going to graph all the values that are bigger than -2. For the next one, since x is less than 3, we're going to mark 3 on my number line. This is also an open circle because it is strictly less than, and we're going to shade all the values that are smaller than 3. Now, something that's a little bit different to topic 7, because we're dealing with compound inequalities here, I'm being very specific with where I label my numbers on the number line because I will ultimately have to just graph one number line. So, in order to write this, our question is asking us to graph all real numbers that are greater than -2 and less than 3. So if we want to rewrite this, this is x is greater than -2 and x is less than 3. There is another way that we can rewrite this in a more compact way. The compact way is -2 is less than x, which is less than 3. And I'll show you how we can see that on the graph in a moment. So if we want to graph all real numbers that are both greater than -2 and less than 3, we want to think about an example that satisfies that. So on my graph, I'm going to label where my -2 is and where my 3 is. We know that they're both open circles because of the inequalities. It's strictly greater than and strictly less than, but we need to determine where we can actually shade on our graph. So if we think of an actual example that satisfies that's both greater than -2 and less than 3, let's think of an example such as when x equals -1. That satisfies both inequalities. It is greater than -2, but it's also smaller than 3. In fact, all of the values that are in between -2 and +3 will satisfy this. And this can include both whole numbers and also decimals and fractions. If we look back to our two graphs and we were to actually put them on top of each other, the part that would be shaded together that would cover for both graphs is this section right here. So for an and graph, that's where we're going to shade. Also, as I mentioned before, we can rewrite this in the compact way. -2 is less than x is less than 3. This x is sitting sandwiched in between -2 and 3, just like the shaded portion on the graph here. Let's go to the other example for a union. Union is another way of saying or. This is when a number is a solution to the compound inequality if the number is a solution to at least one of the inequalities. So definitely and is more restricting. It needs to satisfy both of the inequalities. However, for or, it just needs to satisfy one. It can satisfy both, but it just needs to satisfy at least one of them. So our example here, we have graph all the real numbers that are less than -2 or greater than 3. So we have x is less than -2, or we have x is greater than 3. Since x is less than -2, we're going to graph this on our number line. This gives us an open circle, and we're going to shade to the left all the values that are smaller than -2. And for when x is greater than 3, we're going to graph our 3, again, open circle because of the inequality, and shade to the right all the values that are bigger than 3. Now, if we think back to what our problem is asking, it says graph all the real numbers that are either less than -2 or greater than 3. That's a key word that I like to toss in for inequalities when we're dealing with either or both and. So for and, it needs to satisfy both inequalities, whereas for or, it needs to satisfy either one of them, at least one of them. So this inequality, if we were to write it in compound form, we have x is less than -2 or x is greater than 3. Now there isn't another compact way to write this, unlike the and form, so we would just leave it as x is less than -2 or x is greater than 3. However, let's think about an example that satisfies either of the inequalities, or at least one of them. Something that is either less than -2 or greater than 3. Well, we have so many options for numbers that are less than -2. -1, -2.5, -10, on and on and on. We also have a number of answers that fall under x is greater than 3. 4, 5, 100, 10,000, etc., etc. So we just need a number that satisfies at least one of the inequalities. For an example, let's say x equals 4. It satisfies at least one inequality. So let's graph it. We have -2 and 3. Again, we have both open circles, but since this is an or graph, we want to think all of the numbers that are less than -2 or greater than 3. In this case, our 4 will line up right here. And since that only satisfies one of the inequalities, we're all set, we're good to go. Oftentimes, you might hear people refer to, for compound inequalities, if it's an and, you shade in between, and if it's an or, you shade away. That is not always the case though, so it can be helpful for some students, but you have to really make sure that you're reading the inequality properly to make sure that you aren't ignoring any possible solutions. Let's go into some other examples. Let's graph x is less than -2 and x is greater than 3. So if x is less than -2, I'm going to graph that separately first, just like we did before. This is an open circle. X is less than -2, so we're going to shade to the left-hand side. For x is greater than 3, again, open circle, but we're going to shade all the values that are bigger than 3. Okay, if we think back to our inequality though, this is and, so it needs to satisfy both inequalities. Can you think of a number that is both less than -2 and bigger than 3? No, there is actually no value of x I should say that satisfies, not an English teacher. That satisfies both inequalities. So on our graph of -2 and +3, this is actually just no solutions. Our next example says graph all real numbers that are greater than -2 or less than 3. So in this example here, we have x is greater than -2 or x is less than 3. If x is greater than -2, we're going to have an open circle at -2, and we're going to shade to the right all the values that are bigger than -2. If x is less than 3, again, we have an open circle because of our inequality, and we're going to shade all the values that are smaller than 3. Now, because we need values that will satisfy at least one of the inequalities, let's think some examples that are either greater than -2 or less than 3. If we were to put these two graphs on top of each other, what would our number line look like? Well, if we think about numbers that are greater than -2, that's -1, 0, 1, 2, 3, 4, 5, 6, etc., etc., all the way up to positive infinity. If we think of numbers that are less than 3, that could be -2, -1, 0, all the way to negative infinity. So our values actually cover each other on the graph. So we have our circles at -2 and +3. And if something that is bigger than +2 is actually going to go over the 3, and see how my circle has now actually filled in over the 3? Same thing if we want to go the other way, something that's less than 3. So in this case, our entire number line is actually covered. Our answer here is called all real numbers, because all of the real numbers on our number line are actually shaded, and they would satisfy at least one of the inequalities here. That was part 1 of topic 8 for Algebra 1, writing, graphing, and solving compound inequalities. Thanks for watching.